All right, then. Yeah, I'm here today to talk to you about the Glean UniFFI migration we recently did and how barely anyone really noticed. I had to slightly adjust the title in the past weeks about that. So, as you all know, Glean or the Glean SDKs are how we collect data in pretty much all of the Mozilla products by now. And on the right here, you see a diagram of the rough structure of how Glean was structured before this migration. And this is essentially how Glean is built on several layers. On the very bottom layer, we have a Rust core implementation. This is where we implement most of the logic, the data storage, the data model. It's also where we implement how we encode data into the payload of a ping that we then send out. But it leaves out a little bit of stuff that we defer to the final application later. On top of that, we have what we call the FFI layer, the foreign function interface. This is an abstraction above the very low-level core library that uses foreign function interface that most other languages can actually speak. This is essentially what you would do if you have a C library, but Rust can also do that, and then other languages can use that. All of this code was manually written back then. On top of that, we have the foreign language implementations. This is the Glean Kotlin SDK, the Glean Swift, and the Glean Python SDK, which are used in different applications, depending on where they need to run. Kotlin, obviously, on Android, Swift on iOS, and Python on a couple other things. Now, there was a lot of logic still written in these foreign language implementations, especially around the actual upload, integration with the surrounding platform, like the app model on Android. All this was logic that was encapsulated in each of the different foreign language implementations. But logic-wise, there were very similar implementations across Kotlin, Swift, and Python, because it was effectively the same logic we had to duplicate across all of these. And so this meant we had to write a lot of code across these layers to get Glean working on all the platforms we needed it to. So the question was, what if we don't need to write all that code manually at all? And luckily for us, we're not the only ones writing Rust code and shipping that to all the platforms. The app services team did that before us, and we copied a lot of what they did and worked with them to refine how we do things since then. So early on, app services was facing the same problem of needing to maintain a lot of manually written code across multiple platforms. And so they started UniFFI. How did UniFFI work? Essentially, it allowed you to define the API once. Here you see a simple rocket interface where you can build a rocket, you can lock the steering of a rocket, and finally you can launch it. You don't have to understand all the code here in full detail. This is just for illustration purposes. So this is the interface definition of what a rocket would look like. And then we implement this once in Rust. Now we have all the logic in Rust, and this is really just pure Rust code. We can test it. We can use all the Rust crates out there, whatever we need to implement it. And then we take this definition and the Rust code, and we throw it against UniFFI, and then some magic happens. And when this UniFFI magic is done, what we get is something we can call from Kotlin. We're just creating a normal Kotlin object, calling methods on it. We can do the same in Swift, and also the same in Python. And we haven't written a single line of Kotlin, Swift, or Python to actually make all of this possible. That's all the magic UniFFI did for us. So what really is UniFFI? UniFFI is what we call a multi-language bindings generator. It was started as a side project by Ryan Kelly from the app services team back in the summer of 2020, exactly to address this problem of moving away from writing a lot of manual code to auto-generating this code from what we know, what we want to get out as the API. And from the get-go, UniFFI was built to reuse a lot of the known things. It used the same patterns and structure we already use in app services in Glean, where we have the core implementation in Rust, an FFI layer on top, and then the Kotlin or Swift implementation on top of that, calling into the FFI. So it used the same patterns, but instead of manually copy pasting the same implementations over and over again, the tool did that for us. And because we also wanted a single API definition, it started also to use WebIDL, an interface definition language that's already used by Firefox, but also the web spec and in some parts even WebAssembly. So there's knowledge around it, and there's also tooling that we could reuse to use WebIDL for UniFFI as well. So this project quickly became larger and became a real success for all the teams and for Mozilla. So UniFFI is really a success on multiple axes. First off, app services migrated most of their components by now, one by one. They have multiple components that are very separate, and so they're able to do this one component at a time. And by now, there's only like 2 or 3 components that haven't migrated to UniFFI, but that's still the plan. And also UniFFI allowed for frequent cross-team work between the Glean team and the app services team, making sure we implement all the features that different parts of Mozilla need, different Mozilla products need, and also allowed us to share the ownership of UniFFI between those teams. On top of that, UniFFI is a success as an open source project coming out of Mozilla as well. Because all of this code was available, others started using it, and by now we have outside users as well as outside contributors bringing back ideas and features to the project itself. For example, people from Matrix are actually now building some of their tools and mobile applications on top of UniFFI as well, and bringing new ideas in that we might eventually also use. So what did we get by outside contributors? We actually got more language support. There is now a Ruby binding. So if anyone wants to write Ruby stuff with Rust underneath, here you can go. We got new features. As I already mentioned, Matrix folks are providing some of these, which we might actually end up using as well. And also, UniFFI was a pretty good way for us to do some knowledge sharing with other tools that are already out there, such as Diplomat RS, in some cases very similar, but in other cases very different tool. And so we sat down with engineers from them to see what are the weaknesses and strengths of either tool, and can we copy some of the good ideas over. And so how is Glean built now? Before, we already had these different layers that were manually implemented. And as you can see here, we still have effectively the same structure of the Glean SDKs. But now this whole middle part is fully implemented by using UniFFI. We have the API defined exactly once in this definition language. We have the full implementation in Rust, and then have UniFFI to generate all the bindings for Kotlin, for Swift, and for Python, and for fun, I even once generated them for Ruby and use them from that, but we don't maintain those. There's a little bit of code still in these target languages to adjust the API here and there. Kotlin, Swift, and especially Python are very different languages, and not all API patterns work all the time. So sometimes we need additional code to make sure the APIs work for the target language. So what did all of that migration now get us? So you can see from this graph, a lot less code. Before, on the old version of Glean, which was version 44, we had just over 40,000 lines of code in the Glean repository, with the majority in Rust, but a lot of code actually implementing some logic in the target languages. Now, after the migration, we are just over 30,000 lines of code. And as you can see, a lot less code for all the languages, even Rust. And this is because we could also drop a lot of the FFI implementation. Now, what you don't see from this graph, if we take into account the code that's actually generated, we're probably above the 40,000 lines of code again. But again, this is a lot of code we don't need to maintain. It's guaranteed to be generated the same all the time. But less code is not all we got from this. So what else? We now can guarantee that we have similar APIs across all the target platforms without additional effort. Previously, because everything was manually written, we had to copy over the APIs, make sure they work for the target platform. And if we ever change it in one target platform, we also need to remember to change it in the other places. We don't need to do that anymore. It's defined once. This makes it much easier going forward for us to actually add new metric types. We can define them once, generate all the code, and have them available on all platforms right away. And if we figure out that a new metric type, for example, does not work on a specific platform, that's a very good hint that maybe the metric type needs to change and not necessarily the API itself for different platforms. What we also got now is much more consistent testing. Because we have all the logic implemented in Rust, we can do most of the testing in Rust now. There's no need to test all the individual APIs on the high-level languages anymore, because all the logic is in Rust anyway. This also makes it much faster for us to test. On top of that, because we now have less moving pieces in there, we can now more easily ship an iOS Megazord, which is the name for shipping all of app services and Glean together on iOS. And UniFFI was already targeted to be included in Mozilla Central for additional components, both from app services, but potentially also new stuff. But because we were the first ones to actually use UniFFI from Mozilla Central, they can now just use it and don't have to deal with a lot of the integration problems we had to deal with to begin with. So this was a lot of the technical stuff behind how we did the Glean migration or why we did this. Now I'm going to talk about how we actually rolled out a new version of Glean to Android in June of this year. So again, this is like the new version was titled Glean version 50. The old version was version 44. We decided to just jump ahead a couple of version numbers because this is actually a nice round number. It's easy to communicate that this is some major release that potentially has some impact. But our plan there also was to make sure actually this shouldn't have big impact to any users. So how did we do this? The first plan to actually do this migration from the old code structure to UniFFI started in July 2021. I wrote a proposal discussing a lot of the technical details, how we can do the migration, discussing some options of whether we can do that incrementally or all at once, and discussed some things that we still needed to implement, especially in UniFFI, to get all this work done. This proposal took some time to actually be discussed and accepted, but by October 2021, we finalized the proposal and finally started with the development. By then, it was also clear that we can't do this incrementally. We need to rewrite everything and then deploy that at once, because the changes we had to make were deep in the inner core implementation of Glean, and we couldn't support both ways of structuring the code in a single code base. Together with Travis, I went ahead and started migrating the code over and over, with me writing a lot of the code and Travis being around for reviews, but also understanding the code, double checking that the code I wrote actually makes sense, and also to understand how the code works so that I'm not the only one with knowledge about the code base, obviously. Along the way, we also had to fix a lot of smaller bugs in UniFFI. So sad app services started migrating a lot of their components, but because, for example, they hadn't any Python consumers, Python support in UniFFI was there, but was a little bit more buggy than the other target languages. On top of that, not all features that Glean needed were needed by app services, so we're also not fully developed by the time we needed them, so we contributed them back to UniFFI as well. Now, you might wonder, October 2021 to now, that's quite a long time. And with only 2 people tasked with this migration, we also had to attend other work. There was still the Glean that was in production use that we had to support. There were a few additional features on Glean that we had to develop, and a lot of the other data work. So sometimes the UniFFI migration was deprioritized, and that way it took a little bit longer than I would have hoped for. But by May or so this year, we were finally at a point where I was confident that we can do the migration all at once and can roll it out. In May 2020, I thus started writing a rollout and testing plan that was very detailed on how we can do this without causing big problems. In this proposal, I put down very careful consideration of the impact that this update will have. That meant I needed to coordinate the timing of this landing. I wanted the maximum span of time in a nightly release cycle to make sure that if anything breaks, we have enough time to actually fix stuff. I also talked to QA early, so they have spare cycles to actually run additional QA tests on the rolled out Glean version 50 to make sure we didn't break any obvious things. And I worked very closely with the affected teams, so they knew this thing was coming, but also clearly communicating to them, at best, they shouldn't really notice. And if something breaks, they knew where to reach us. And also what to look out for, what could break. And then I also put up some monitoring dashboards. So again, the idea with this whole update was that nothing should change for any data consumers. So I put up some monitoring dashboards that looked at important numbers from desktop, from Focus, and from Phoenix, especially around the number of clients we see, the overall ping volume we see from those, as well as the number of errors we record for different metrics. And if we do everything right, none of these graphs should look any different with or without this new version of Glean. At best, even, the error dashboard will just show a downwards trend because maybe we fixed a bug in some metric. And last but not least, there was an explicit go, no-go decision in this plan, as well as a way that we can do a rollback of this whole rollout in case the time we have in the nightly cycle isn't enough to fix all the bugs we encounter. Equipped with this plan, we landed Glean version 50 in Phoenix Nightly version 103 on June 9th. That was slightly delayed from the nightly cycle, so we lost a couple of days. I'll get to that later. So, did anyone notice? I announced that several times within the data meetings, but outside of that, and outside of those people that already were informed, no one really noticed because not much changed. QA finished their runs on June 15th. They didn't find anything of interest. The tests ran just fine on the old version, on the new version, exactly the same. I went ahead and did like daily monitoring of the dashboards we had, and then wrote a full summary of the analysis just about a week after the rollout. So a week is usually the time we collect data to make sure we encounter for most of the users getting the update and also sending us data. So what did we notice in this document? We did notice a few spikes in errors. This is the graph of one particular metric from Nimbus on Focus Android that suddenly spiked, or at least that we did notice a spike in. But if you remember, the Glean version 50 was rolled out on June 9th. And as you can see from this graph, this metric showed errors from somewhere around May 10th or so. So it turns out this particular metric was not affected by the Glean rollout at all. It's just that us closely monitoring this data suddenly made us realize there is some error. So we went ahead, reported that to the data owners, they fixed it, and now it's all good. There were a couple of more metrics that essentially had the same pattern. No one looked at them in time to notice any errors. Now that we looked, we noted that, we reported it, but nothing of that was attributable to the Glean update. One thing, though, was caused by Glean version 50. That was a startup regression for both Phoenix and Focus. The time it takes from you clicking the icon on your smartphone to the app actually opening and you seeing that is quite substantial on especially old Android phones. So the performance team keeps a close eye on how much time that actually is. And we noticed with this Glean update, there was a regression of up to 60 milliseconds, which might seem very low, but in the overall thing where this thing should start really fast, 60 milliseconds are noticeable, as you can see from this graph. And this was actually caused by the Glean changes. There was some changes how we load Glean at startup that caused things to be loaded earlier than they were necessary. And by now we fixed that by just deferring loading Glean again, the same as we did before. And we are down the 60 milliseconds that we had increased by this update. And so what else did I notice in my analysis? Well, as I said before, integration of the update into Android components in Phoenix and Focus was delayed by a couple of days. These were basically minor bugs in how we do version updates on Android tooling. We addressed them by now. We were around and worked with the release team to actually get them fixed. But for 2 or 3 days, we actually blocked updating Gecko View, which Android folks were definitely not happy about. And I probably owe some people some cold drinks now. But we got through that and have addressed that now. And going forward, we shouldn't cause any more of these problems. Another thing that we noticed is an increase of failing tests that tested Glean functionality within Android components. And it turns out, again, this was a bug in the test APIs Glean provides. We fixed them by now, but another outcome of that was this particular failing test could actually not happen in any of the actual application runs because the bug was only in the test APIs. So again, it's the test APIs that were broken and not necessarily Glean itself. So Glean version 50, was it all good? Probably not exactly. All the analysis was done on Phoenix and Focus nightly, just so we had enough of time. And then the data rolled through the release cycle. And by July 19, version 103 of Phoenix was released on the Google Play Store. Shortly after that, on or around July 24th, Chris Peterson noticed that there was some data missing from this particular version of Phoenix. And just a day later, in our weekly triage meeting for the Glean SDK, we also noticed some error increases. So we started looking into that, noticed that indeed there is data missing from this version. So we called a data incident. So what happened? From Glean version 50 on, exactly this new Glean with UniFFI, we missed reporting exactly 4 metrics that we promised to always report from Android. These included the Android SDK version, the user's local, as well as device manufacturer and device model. 4 metrics that are not like super important and definitely not included in a lot of the dashboards, but sometimes are very useful to understand some of our data better. So it was essential that we bring this back. The bug was fixed in Glean on the same day. It really was an oversight and a bug in Glean. We fixed the bug, we added tests to make sure this doesn't happen the same way again. We rolled this out first to Phoenix Nightly again, but then by July 29th, we had that in version 104 beta. So we uplifted that to make sure we don't have this bug for a long time. And then subsequently, we actually also fixed that in release now because there was a patch release going out for Phoenix anyway. We managed to fix this bug as well. So since August 3, there's no new version of Phoenix anymore that's losing this data. So there's only a very small time frame on version 103 that doesn't report this data, but everything beyond, and especially version 104, when it goes to release, will have this data just fine. So by now, we're actually up to Glean version 51. While all this bug fixing was going on, we also worked on removing some functionality that we added during the migration that wasn't really needed. So is everything good now? It seems so. We haven't heard any other reports until now. So what have we learned with all this? Well, data folks sure like to always be migrating. I do not plan to do this for the Glean SDK at all anytime soon again. But what really helped with this project was to start the plan early. As I said, it took from July last year until about July this year to roll out this whole thing on Android at all. But making a very detailed plan and involving stakeholders very early on made it possible for us to plan this out, be very detailed about the things we do, and ensure that we are tackling this from all sides and making sure essentially no one should notice. What we also saw again, and this is not necessarily new, is that data always uncovers problems, but the problems it uncovers are not always your own. And one thing that the latest data incident showed, again, is that nightly and beta data is definitely not as closely monitored from either the data teams or the product teams as release data is. And this surely is a problem because we could probably detect some things earlier, but it's also not an easy problem because our populations on nightly and beta are so different that just a plain look at the data won't uncover these problems either. But there's definitely something that we can and should do to make it easier for us to detect some of the problems even earlier. Before I close, a big thanks to the whole Glean team, Alessio, Chris, Travis, and Perry. All of them helped with this in some form or another. Big shout out to the application services team doing a lot of the Rust work ahead of us and working closely with us to make sure we can ship our Rust stuff all across Mozilla. Again, a shout out to the UniFFI team, which is not only Mozilla folks, but also outside contributors. Big shout out to Mozilla Android team, who were always around and very helpful in making sure we can get our stuff landed. And last but not least, a shout out to the release team, especially to Ryan, who helped a lot with getting our releases done quickly and sometimes even skipping the queues to make sure we're not blocking Phoenix releases again. Thanks.